Hello, fellow Americans. Thank you for tuning in to CHE Channel 10. I'm Andrew Clark.
And I'm Nicole Heineshin. Today we have a special report on technologies concerning the capture of carbon dioxide from coal power plants. Andrew, I understand you've done some background research on this topic.
Indeed, I have. Coal-fired power plants generate 44% of electricity in the United States, while simultaneously being the largest air polluter. A typical 500 megawatt plant burns nearly 1.4 million tons of coal per year and emits 3 million tons of carbon dioxide. Americans use this power every day, completing simple household tasks such as turning on the lights.
Oh, very interesting. When coal undergoes a combustion reaction, carbon dioxide is formed, which is a major contributor to greenhouse gases. Greenhouse gases are the leading cause of climate change. They trap in heat radiation from the sun, which warms up the atmosphere. Coal produces more carbon dioxide per combustion than natural gas and other fossil fuels.
It is very important to reduce the amount of carbon dioxide in the atmosphere for the future of our planet. Carbon dioxide may be captured by plants and microorganisms. Plants utilize photosynthesis, which uses carbon dioxide as a reactant to form glucose and oxygen. Carbon dioxide can diffuse into the ocean to reduce its concentration in the atmosphere. Since 1990, the United States has acted as a net sink of carbon dioxide. This means that more carbon dioxide is stored in the land and plants than is emitted into the atmosphere. This sink only offsets the amount of carbon dioxide produced totally by the United States by 15%.
Technology is being improved, and scientists around the world are trying to find a solution to these problems. A carbon dioxide reduction strategy is switching to a new, cleaner fuel. However, this would be very difficult to change all existing technologies to use a new fuel. A more plausible solution uses CO2 capture and storage on coal-fired power plants.
Carbon dioxide capture and storage technologies have the ability to significantly reduce the amount of greenhouse gases emitted into the Earth's atmosphere. They can work up to 90% efficient. These technologies would save as much carbon dioxide as planting 10 trees and waiting 10 years for them to grow. Actually, 62 million trees! Carbon dioxide capture and storage provides a low-cost solution to reducing greenhouse gases when compared to using completely new fuel sources.
Now we'll head out to Middle of Nowhere, Canada to our expert in the field, DJ Cook, to discuss methods behind these technologies.
Thanks, team. Today I am on location at the nearby coal power plant, a perfect backdrop to discuss today's subject. There are three technologies used to capture carbon dioxide. They are post-combustion, pre-combustion, and oxy-fuel technologies. Today we will be focusing on post-combustion and oxy-fuel. Post-combustion separates this carbon dioxide gas after the combustion of the coal. The main technology used is absorption. Absorption uses a liquid solvent that has the ability to dissolve CO2 and then carries the CO2 where it's released to form a CO2 gas stream. The defining feature of oxy-fuel technology is the separation of oxygen gas out of the air entering the boiler. This produces a flue gas stream that is comprised mostly of CO2 and water vapor, which can be separated into its individual components. Pretty neat, eh? Alright, back to you, team.
Thank you, DJ. Now we'll head out to a super secret location with Dr. Daniel J. Cook.
Hello, I'm Dr. Daniel J. Cook, and here we have the flowchart for absorption, the main method behind post-combustion carbon dioxide capture. Here we have our flue gas, which is leaving our power plant, and it enters the absorption column, where the liquid solvent flows down. The CO2 gas in the flue gas absorbs into the liquid solvent, and the liquid solvent moves to the regeneration column. In the regeneration column, the conditions are altered so that the solubility of CO2 is reduced, and the CO2 actually desorbs and forms a CO2 gas stream. And then the liquid solvent can be reused. 70 to 80% of the additional energy needed in this process is used in the regeneration process for the liquid solvent. The good news is the resulting CO2 gas stream is often over 99% pure. The total additional energy costs reduce the efficiency of the plant by 9 to 14% and lowers the net power generation by 20 to 35%. Here's our flowchart for oxy-fuel combustion. We have our air separation unit, which separates ambient air that is 79% nitrogen and 21% oxygen into pure nitrogen and oxygen streams. The oxygen gas stream enters the boiler, and the resulting flue gas stream is comprised of mostly CO2 and water vapor, which can easily be separated after it goes through the condenser and separation unit. Air separation currently is capable of producing an oxygen gas stream with over 90% purity. Unfortunately, this process takes a lot of energy, and the total additional energy costs reduce the efficiency of the plant by 7 to 11% and lowers the net power generation by about 15 to 30%. Good news is the resulting flue gas is reduced in volume by about 75%, and once the water vapor is condensed, CO2 comprises 80 to 90% of the flue gas volume. All right, back to you, team.
Okay. Thank you, Daniel. We'll send it over to our analyst, Catherine McElhinney, who has been hard at work crunching numbers.
There are pros and cons to both post-combustion and oxy-fuel technologies. Some of the advantages to post-combustion technology is that it is most cost-effective. It has been used in the natural gas industry for over 60 years. Most of the equipment you need is quite simple and already present in many of the plants. You only need to separate the CO2 after combustion, and this makes the overall process a lot simpler. There are several disadvantages to post-combustion as well, though. One of the disadvantages is that there's a lot of nitrogen in the flue gas stream, up to 70%, and this significantly reduces the concentration of CO2 in the stream, and it also makes it a lot harder for separation. The oxy-fuel technology has its own set of advantages and disadvantages. The main advantage of this technology is that there is no nitrogen present in the flue gas stream. This makes the concentration of carbon dioxide much higher, and it's also easier to separate the carbon dioxide because the only other element present is the water in the form of steam. The size of the boiler can also significantly be reduced because there is no nitrogen present, and it takes less energy to heat the oxygen entering the boiler than it would to heat the nitrogen and oxygen in air, since nitrogen is separated in the first step of the process. A final advantage of the oxy-fuel technology is the recycled flue gas stream. This helps control the boiler temperature, so it does not take energy to control the boiler temperature. There are several disadvantages of the oxy-fuel technology as well. One disadvantage is that small amounts of nitrogen gas can still enter the system if it's not completely closed off. A second disadvantage is that there can be impurities such as sulfur dioxide present in the flue gas stream, and this can corrode some of the equipment. The main disadvantage, however, is that an air separation unit is very expensive and it's not present in most of the coal power plants currently today. And once air separating becomes easier and more economically feasible, the oxy-fuel technology should be much simpler.
Thank you, Catherine. In case you're just tuning in, today we've discussed two technologies concerning the capture of carbon dioxide gases from power plants.
Currently, we use post-combustion capture due to its ease of implementation in power plants and its cost-effectiveness. However, this method has a much more complicated separation process.
The other technology discussed is a new and expanding approach known as oxy-fuel capture. Let's look at some of the pros and cons of this developing method. The flue gas contains mostly carbon dioxide and less impurities or unwanted gases. Oxygen alone requires less energy to heat than air does. Also, the equipment can be smaller due to lack of nitrogen.
Some negative effects of oxy-fuel include higher concentrations of impurities such as sulfur dioxide that can corrode equipment. In addition, air separation into individual oxygen and nitrogen components is very expensive. Here at CHE Channel 10, we've concluded that due to the productivity enhancement by using oxy-fuel, it will be the leading method of carbon dioxide capture. I'm Andrew Clark.
And I'm Nicole Heineshin.
Don't have just a great night. Have an American night.
Stay classy, Pitt.